Hello everyone, you are learning physics from Uncle Irodov, and in this module I will be solving Irodov's 1.10. Now in this problem there are two bodies which are thrown from the same point at the same time. One, which I have labeled as A in the figure here, is thrown up, it goes up, stops, and then it falls down, while the other one, B, is thrown at an angle theta, whose value has been given here in the problem statement, and what they want is the distance between the two bodies at a certain time later. Now the basic idea behind this problem is this. Suppose I were to view the situation from one of these bodies' viewpoints, so either from the viewpoint of A or from the viewpoint of B. So let us say we view everything from the viewpoint of A. So if I look at everything from the viewpoint of A and at any given amount of time draw this vector that is directed from A towards B, then the length of that vector would be the distance between the bodies. Then this becomes a very simple problem because then we can take advantage of the vector algebra. Now if you have a look at the top right hand corner where I am drawing a new sketch, suppose O is our origin and suppose there is a point A and suppose there is another point B, and then also suppose that the vector drawn from O to A is RA and the vector drawn from O to B is RB. Then the vector drawn from A to B can be easily found out because this will be the difference of RB and RA. That is what our strategy will be here. We will find out what is RA at any instant. We will find out what RB is at any instant. And then we will find out R of B with respect to A, and then we will find the magnitude of that vector. For example, A goes up. Now using this point, if you look at the figure or the sketch on the left hand side, using this point O as the origin, the displacement of A is ut plus half a t square, and displacement is RA final minus RA initial, which was anyway 0 because A was initially at origin. So SA itself is equal to RA. Next, for SB, you will notice that this is the vector which I am drawing in blue from origin to B. Now the displacement of B is ut plus half at square, that is this. This is in fact R final of B minus R initial of B, and this is again 0. So RB final is the displacement of B. Now once we know the values of RA and RB, we can try to find out the value of R of B with respect to A, which I am using here as S of B with respect to A, that is SB minus SA, and that is this whole vector. Then the distance between A and B is simply the magnitude of this vector, which is of course the x component square, which is v naught square cos square theta into t square, and t I have taken out, and then the y component square, which is v naught square sin square theta plus v naught square minus 2 v naught square sin theta, which can be simplified to look like this. Now in this, if we insert the value of t is equal to 1.7 or approximately root 3, because root 3 happens to be 1.732 and so on, we will get the distance between A and B at this given time, 1.7 seconds, as approximately equal to 22 meters. I hope you have learned something in this module, and I also expect to see you in my later modules. Bye.